Hello students, today we are going to study very important chapter in physics in heat and thermodynamics, that is calorimetry. In the chapter of calorimetry, we will study about the mixture temperature, about the heat exchange. What happens when a high temperature liquid or solid is mixed in low temperature liquid or solid, and how the phase change takes place. All these types of what is water equivalent, what is specific heat, all these types of definition we will look in this chapter. So let's start calorimetry. The things which we will study here: what is heat, what is specific heat, types of specific heat, thermal capacity, principle of calorimetry, water equivalent of body, latent heat and heating curve. Okay, one by one we will study. Let's understand some important definitions. What is specific heat? It is written by letter S, and it is defined as, or sometimes it is defined as delta Q upon m delta theta. So dear student, if we keep m equal to 1 gram, delta theta equal to 1 degree centigrade, delta theta is change in temperature, then C or S will be equal to delta Q. If m equal to 1 gram and delta theta equal to 1 degree centigrade, that is change in temperature, then specific heat is equal to quantity of heat supplied. So dear student, how do we define the specific heat? The specific heat of a substance is defined as quantity of heat supplied to one to change the temperature of 1 gram of substance by 1 degree centigrade. Quantity of heat supplied to change the temperature of 1 gram of substance by 1 degree centigrade. And what is its unit? Unit is calorie upon gram degree centigrade. Calorie upon gram degree centigrade. For water, remember, specific depends on the temperature as well as nature of the substance. Specific depends on, specific is a function of temperature and nature of substance. Dear student, for a given substance, there can be infinite value of specific heat. Okay, because it depends on temperature. At different temperature, specific heat will be different. Like for water, specific heat is 1 calorie upon gram degree centigrade when we take 1 gram water and change the temperature from 14.5 degree centigrade to 15.5 degree centigrade. Okay, so let's remember some important specific heat, that is specific heat of water. This is 1 calorie upon gram degree centigrade, and 1 calorie can be written as 4200 joule upon kilogram degree centigrade. Specific heat of ice, it is 0.5 calorie upon gram degree centigrade, that can be written as 2100 joule upon kilogram degree centigrade. And specific heat of steam, This I am marking as a star because sometimes in numerical problem it is written different. This is 0.47 calorie upon gram degree centigrade. What is the physical significance of specific heat? Let's see. What is specific heat? Delta Q upon m delta theta. Dear student, if value of specific heat is less, means if value of specific heat is less for a given substance, what this indicates? Less amount of heat will be required to bring same change in temperature. What is meaning of, what is physical significance of specific heat? If value of specific heat is less for a given substance, means what? Less amount of heat will be required to bring same change in temperature in given substance. Okay, that's why for cooking utensil what we expect, specific heat should be low. For ideal cooking utensil, specific heat should be 0 so that its temperature can be increased instantly. Okay, if we talk about the coolant, coolant is a substance that cools other substance. The coolant can cool other substance when its temperature will remain less. Okay, so for specific heat for ideal coolant should be infinite. Okay, or we can say in general way specific heat for coolant should be more and more. Okay, now let's learn about the heat capacity. This ms is called heat capacity. Its unit is calorie upon degree centigrade. Dear student, when this degree is written after C, it indicates change in temperature. When it is written before C, it indicates temperature. Okay. So what is heat capacity? When delta theta equal to 1 degree centigrade, then ms equal to delta Q. So heat capacity of a given substance can be defined as quantity of heat supplied to change the temperature by 1 degree centigrade. Okay, what is difference between specific heat and heat capacity? Specific heat is the quantity of heat supplied to change temperature by 1 degree centigrade for 1 gram of substance, and this is not for 1 gram of substance. This is the quantity of heat supplied to change temperature by 1 degree centigrade for given amount of substance. For given amount of substance, okay, that is the difference. If it is for given amount of substance, then it is heat capacity. If it is for 1 gram of substance, it is specific heat. And heat capacity depends on nature of substance, temperature, as well as amount of substance also. Okay, dear student, heat capacity depends on amount of substance, nature of substance, and temperature. It is different for liquid, solid, and gas. Okay, now dear student, we will learn about water equivalent. Water equivalent. It is written by letter W. See, what is water equivalent of a given substance? Suppose we are taking example of this pen and we are supplying delta Q quantity of heat to this pen. On supplying delta Q quantity of heat to this pen, let us assume the change in temperature comes out to be delta theta. Now, How much corresponding quantity of water either in liter, gram or kilogram should be taken? How much corresponding quantity of water either in liter, gram or kilogram should be taken so that on supplying same quantity of heat to this water, the change in temperature also comes out to be same. Okay. Then this corresponding quantity of water, either in liter, gram or kilogram is called water equivalent. In numerical, the water equivalent plays the role of water in term of heat calculation. In numerical problems, the water equivalent plays the role of water in term of heat calculations. But while defining mixture content, it does not become water because it is not water. Because many times in the numerical problem, specific heat for the container is not given, and whenever a content is heat up, content always remains in thermal equilibrium with the container. When content are heat up, container also heat up. But when specific heat for the container is not given, then in that calculation heat is required to increase the temperature of the container also. In that situation, water equivalent is given. Okay. So dear student, what we do? What water equivalent plays? Water equivalent plays the role of water in term of heat calculations. Okay. But while defining mixture content, it does not become water because it is not water, it is the container. Okay. Hope you understood the meaning of, and in numerical problem you will better understand. Okay. In numerical problem, water equivalent will play the role of water in term of heat calculation. Okay. But while defining mixture content, it will not become water because it is not water. Okay. Now let's understand some more definitions. Latent heat. This heat is utilized during state change. Okay. When conversion of solid takes place into liquid, or conversion of liquid takes place into vapor or steam, then this latent heat comes into picture. How the latent heat is defined? This is very important in solving the problem of calorimetry. How the latent heat is defined? See, we write delta Q equal to ml. Here L is latent heat, and dear student, this L is what? Delta Q upon M. This is how latent heat is defined. This is of two types: latent heat of fusion and latent heat of vaporization. Okay. Now let's see. If M equal to 1 gram, then L equal to delta Q. So what is latent heat? It is the quantity of heat to change the state of 1 gram of substance at a given reference temperature. It is the quantity of heat to change the state of 1 gram of substance at a given reference temperature. This given reference temperature word is very important. And what is this given reference temperature? This given reference temperature can be either boiling point of liquid or can either be melting point of solid. If the given reference temperature is melting point of solid, then it is called latent heat of fusion. If the given reference temperature is boiling point of liquid, then it is called latent heat of evaporation. So dear student, what is latent heat of fusion? It is the quantity of heat required to change 1 gram of solid into 1 gram of liquid at its melting point is called latent heat of fusion. Remember, during state change, temperature of the substance do not change. Okay. During state change, temperature of the substance do not get changed. During state change, whatever heat you supplied, that is utilized in changing the intermolecular separation. During state change, whatever heat you supplied, that is utilized in changing the intermolecular separation. And what is latent heat? This is latent heat of fusion. Whatever heat you supply, this is called latent heat of fusion. Latent heat of fusion. And for ice, its value is 80 calorie per gram. And what is latent heat of vaporization? The quantity of heat required to change state of 1 gram of liquid at its boiling point to 1 gram of vapor is called latent heat of vaporization. And for water, its value is 542 calorie per gram. For water, its value is 542 calorie per gram. Okay. So dear student, this was about the latent heat. Now I am telling you about the heating curve. Okay, heating curve. By taking one example, I am explaining you heating curve in a very simplest way. Heating curve. This curve is very important, and in almost all corporate examination usually questions asked on this heating curve. Let us understand what happens when heat is supplied to some amount of ice, okay, at temperature minus 4 degrees centigrade, okay. Suppose we are taking ice at minus 4 degrees centigrade, then what will happen? If you supply the heat, always remember, whenever temperature change will take place in numerical problem, you will use ms delta theta. Whenever state change will take place, you will use ml in numerical problems, okay. So dear student, when heat is supplied to ice at minus 4 degrees centigrade, then this ice will attain its temperature 0 degrees centigrade, that is its melting point, okay. So heat will be absorbed by the ice. Now again, if you supply the heat, then it will convert into water at 0 degrees centigrade. I told you during state change, temperature of the substance will not change. Now again, in this case, you will use ml. Now, if you supply again heat, what will happen? Temperature of water will get increased up to its boiling point, that is 100 degrees centigrade. If you supply again heat, what will happen? This water will convert into steam of 100 degrees centigrade. I told you during state change, temperature of the substance will not change. If you again supply heat, what will happen? Temperature of the steam will get increased. It will become more than 100 degrees centigrade. So this will be based on all this. We will be drawing the heating curve. Okay. Now let's see. This is the general picture of heating curve. I am drawing proportional diagram. Okay, so that you can understand everything very clearly. Dear student, this is temperature and this is heat supply. Or time, because heat equal to what? Power into time interval. Okay, if constant power source is used. Now, if the temperature of ice was minus 4 degrees centigrade, then this is temperature 0 degrees centigrade. Now here complete 100% ice is there in the root. Okay, here 100% ice is there. At this point also 100% ice. Okay, now state change will take place. At this point, this is 100% water. Now again temperature will increase. Okay, again temperature will increase. Here slope of this curve is less than slope of this curve, because specific heat of water is more than specific heat of ice. Okay, when specific heat remains more amount of heat will be absorbed by the water to bring same change in temperature. Okay, now dear student, the temperature has reached to the 100 degrees centigrade. Now again straight conversion will take place. The length of this curve is more than length of this curve, because you will see latent heat of evaporation remains more than latent heat of fusion. So more amount of heat will be required to change same amount of substance in given time interval. Okay. At this point, this is 100% water. And at this point, this is 100% steam. And now again, temperature increase. Here slope is again more, but specific heat of steam is less. Okay. So this is complete heating curve. Okay. For the ice. Now let's understand the slope of various curve. Okay. Suppose this is A, B, C, D, E and F. Here in between, mixture of water and steam at 100 degrees centigrade. In between here, mixture of ice and water, because 0 degree centigrade ice can remain in thermal equilibrium with 0 degree centigrade water. Okay. Now dear student, we know specific heat of steam is 0.47, specific heat of ice is 0.5, specific heat of water is 1 calorie upon gram degree centigrade. And what is delta Q? Delta Q equal to ms delta theta, that is equal to power into delta T. So delta theta upon delta T equal to P upon ms. Ms is heat capacity. Okay, this is the slope of the curve. So you can understand the slope of the curve is inversely proportional to specific heat, because specific heat is least here, then here, then here. So slope will be biggest in slope of EF. Dear student, slope of EF will be more than slope of AB, will be more than slope of CD. This is very important concept. Okay. And here state change is taking place from solid to liquid, from liquid to vapor, because we know latent heat of evaporation is 542 calorie per gram and latent heat of fusion for ice is 80 calorie per gram. So this is approximately 7 times. So dear student, delta Q equal to ml equal to power into time. Okay. So here in case of D, delta Q D equal to m into latent heat of evaporation equal to power into time interval in case of D. And in case of BC, this is m into latent heat of fusion. This is power into delta T in case of BC. So you can find the ratio of time also, okay, by dividing these two equations. What? Latent heat of evaporation divided by latent heat of fusion equal to how much? This is time interval in D divided by time interval in BC. And now dear students, I am telling you about the principle of calorimetry. Okay. Principle of calorimetry. Thus, in simplest word, we can write heat loss equal to heat gain. When two liquids of masses M1, M2, specific heat S1, S2 and temperature theta 1, theta 2 are mixed in a container, then what happens? High temperature liquid loses heat and low temperature liquid gains the heat. Okay. Let us assume, let theta 1 is greater than theta 2 and theta is the mixture temperature. The mixture temperature always remains more than the lowest temperature and remains less than the highest temperature. Okay. So this liquid will lose the heat lost. and this liquid will gain the heat gain. And dear student, remember heat loss remains equal to heat gain, okay? In mathematical way, heat loss and heat gain both are positive term, okay? What is heat loss? M1 S1 theta 1 minus theta equal to M2 S2 theta minus theta 2. This is the general equation. If state change is not taking place, then you will use this equation. If state change will take place, you will modify this equation, okay? If you solve this equation, you will get this relation, theta mixture equal to M1 S1 theta 1 plus M2 S2 theta 2 divided by M1 S1 plus M2 S2. If more liquids are added, then similar expanded form will come, okay? And very important thing about this equation, that this equation is valid even when you mix solid in the liquid, but the condition is that state change should not take place. State change should not take place, okay? This equation is valid when state change do not take place, okay? So dear student, this was all about the principle of calorimetry. Now in the next lecture, we will see important problem. What happens when high temperature liquid is mixed with low temperature liquid, and what happens when water is mixed in ice, and what happens when steam is passed in water, okay? All these things we will study in next lecture, okay? Thank you.